All right, good morning, my Algebra 1 students. I hope you guys had a fantastic day yesterday. I hope you guys understood the material well, and I hope that you're ready to move on. So today we're going to go ahead and start with lesson 7.2, multiplying powers with the same base. Okay, so for this lesson today, you're going to need paper, pencil, calculator, and if you don't have one, you can get a free one on calculator.net. It's beautiful. It works really well. You can use, also we're going to need your textbook on page 426. You'll need to be able to access homework 59, which is out of your textbook. It'll be on page 429. You'll be doing the evens 8 through 20. All right, so we're going to go ahead and get started. If you need to see more what we need today, make sure you just pause the screen, get what you need, and then come back and press play. All right, so for this lesson today, we're going to talk about multiplying powers with the same base. So we're going to talk about, first of all, what are bases and what are exponents. So I'm going to use B for base and E for exponent. So this is our base. Your base is what is your number or your variable that the exponent is attached to. It's telling us this is what we're going to use over and over and over again, but through multiplication. And this is our exponent. And sometimes our exponent's positive, sometimes it's negative, and we've learned already how to take a negative exponent and make it positive from yesterday's lesson. All right, so we're going to learn a rule for multiplying powers with the same base. All right, so that's going to be the very first important thing that we talk about. Okay, so let's take something simple. Let's suppose we have b to the third power. We want to figure out, what does b to the third power really mean? Well, b to the third power really means b times b times b. So now, let's suppose we take that b to the third power, and let's do another b. Let's say b to the fourth power. Well, we know b to the fourth power really means b times b times b times b again. All right, so now, if I was to take these two, b to the third, and multiply it by b to the fourth, I want to find out in exponents, it would be b to the what power? So to determine that, let's look up above. If b to the third is b times b times b, well, that's 1, 2, 3 b's because there are 3 is our exponent. And b to the fourth means b times b times b times b, which is 4 b's because my exponent is 4. So now let's count up how many b's I have all together. Because if I did b to the third, I'd have b times b times b. There's my b to the third. My b to the fourth, b times b times b times b. So now if I multiply those together, I have 1b, 2 b's, 3, 4, 5, 6, and 7. So now I have 7 b's. That means my new exponent should be b to the 7th. So the rule is, I'm going to bring this here up a little bit. Hang on. Okay. When multiplying with the same base, comma, you add the exponents. So we're going to kind of show you that here again using the same setup. All right, so that means if we took b to the third times b to the fourth, since they both had the base of b, we take their exponents, 3 and 4, and we add them together. 3 plus 4 is equal to 7. So the final answer would be b to the 7th, because now we have 3 b's plus 4 more b's, make a total of 7 b's. So when we multiply, as long as they have the same base, we add their exponents. It doesn't work if they don't have the same base. So you have to have the same base. So we're going to go ahead and we're going to move over to page 426. I'm going to bring this down out of the way. Switch out our paper real fast. All right, so here we go. We're going to go to page 426. We're going to do example 1. All right, so example 1, I'll bring this in the view better for you guys, sorry, is multiplying powers. All right, so let's go ahead and take a look at what we got here. We got 12 to the 4th times 12 to the 3rd. And they're asking us to write this expression using the same base. That means they don't want you to simplify this. They do not want to know what the final answer would be, like in a big number. They just want to know what it would be, what would be the base they share, and what their new exponent will be. So let's take a look at that. Our base is 12, and our base is 12. So we're going to bring over our common base of 12. Then we're going to take our exponent. So our first exponent is 4, and our second exponent is 3. And so we're going to add those, 4 plus 3. So then our final answer would be the same base as 12, and 4 plus 3 is 7. So 12 to the 7th power. They do not want you to solve 12 to the 7th. They're saying just rewrite it with the same base and add those exponents. So let's do another one. The second example has -5. It's raised to the -2 power. Then we have -5, and it's raised to the 7th power. All right, so we're going to go ahead and look, our bases are -5 and -5. So since they have the same base of -5, I'm going to bring over that -5. My first exponent is -2, and my second exponent is +7. So I'm going to add -2 plus 7. Once I do that, I'll get my same base, -5, the base they had in common. -2 plus 7 is a +5. So it'll be -5 to the 5th power. Again, they do not want you to solve. They just want you to simplify to here. They just want you to rewrite it with the same base. All right, below that is a got it 1. And then there are 3 problems to look at below that. We have an A, a B, and a C. All right, so we're going to go ahead and look at those. So A has 8 to the 3rd times 8 to the 6th. And I'm on page 426, guys. All right, our B has 0.05 raised to the -3 times 0.5 raised to the -8. And then we have our C value here is 9 to the -3 times 9 to the 2nd times 9 to the 6th. All right, so there are 3 problems that we're going to be looking at. Again, they do not want us to simplify. All they want us to do is bring down our base that they have in common and find out what our new exponent would be. That's it. All right, so let's look at the first one, A. Let's start with Lakeisha. On letter A, what is our base that they both share? That is correct. Our base is 8. So I'm going to bring down the same base they have, which is 8. All right, so Tanaya, what are our 2 exponents? That is correct, 3 and 6. So Isaiah, what am I supposed to do with those 3 and that 6? That's correct, I add them, 3 plus 6. All right, so we'll write our final answer down. So this becomes 8. And what is 3 plus 6, Amaya? That is correct, it is 9. So I'm going to go ahead and box that in. Okay, so let's go ahead and look at the B one. All right, so Cheyenne, What is our same base this time? Correct, 0.5 and 0.5. So I'll bring down that same base, 0.5. I'm going to put it in parentheses because it was in parentheses up here. All right, so what are my two exponents, Mia? That is correct, -3 and -8. Fabian, what am I going to do with those two exponents? That's correct, I'm going to add them. So -3 plus -8. All right, so Laquan, if I bring down my base, which is 0.5, sorry, that's the first one. What do I get if I add -3 plus -8, Laquan? That is correct, I get -11. And again, they're not wanting you to simplify, so don't worry about that. So your final answer is just this. They're not asking you to simplify. Okay, so now we're going to move to the C. All right, Ethan, what is our same base this time? Fantastic, it is 9. There's the 9, so I'm going to bring down the 9. All right, Fabian, what are our exponents? Correct, -3, 2, and 6. Fabian, what am I going to do with those three exponents? That's correct, I'm going to add them. So -3 plus 2 plus 6. All right, so Ava, if you will add those for me, what's -3 plus 2? That's right, -1 plus 6. That is correct, +5. So then this is my final answer. All right, everybody good so far? All right, so we're going to flip in our books then. We're going to go to page 429. So we'll write this down, page 429. This is what the first part of your homework will look like. And this is how I expect them to look when you write them on your paper to turn those into me on either RenWeb Drop. All right, so we're going to start with number 9. Since you're going to do the evens, we'll work the few odds here. So number 9 has in parentheses -6 raised to the 12th power times -6 raised to the 5th power times -6 raised to the 2nd power. All right, so Miss Mia, what is our same base? That is correct. Our same base is -6. I'm going to leave it in parentheses because it was in parentheses over here. All right, so Miss Cheyenne, what do I do with these 1, 2, 3 exponents? That's correct. I'm going to add them. So I'm going to take the 12 and add it to the 5 and then add it to the 2. So this is the work I want you to show me. So I'm going to bring over now my same base of -6. All right, Tanaya, what's 12 plus 5 plus 2? That's correct. It is 19. So then this would be my final answer. All boxed in, so Ms. Hebert knows exactly where to look for her final answer. All right, so let's try one more in this section. We'll do number 11. We got 2 to the 2nd power times 2 to the 7th power times 2 to the 0 power. All right, so let's see. Isaiah, what is our same base? That is correct. It is 2. All right, Laquan, what do I do with these 3 exponents right here, Laquan? That's right, I add them up. So 2 plus 7 plus 0. So I'm going to bring over that same base of 2. So Angel, what is 2 plus 7 plus 0? That is correct, 9. Then this is my final answer. Again, they're not asking you to simplify. They're just wanting you to condense them using the same base. If they say just write using the same base, they're not asking you to simplify to lowest terms. If they want you to simplify to lowest terms and get a single number, they will say simplify. But in the directions that they say rewrite each expression using each base only once, then they want you to take each base, write it once, and give the new exponent. All right, so now we're going to move back, and we're going to go back to page 426 for our next example. So bring this back down, switch out our paper. All right, we're going to go to example 2. All right, example 2 is multiplying powers. In algebraic expressions. All right, so this is what we're going to do. We're going to have an algebraic expression means we're going to have numbers and variables. So you're going to have whole numbers or fractions, and then you're also going to have variables, and you'll have things that are positive or negative. So it's going to be like a big old mashup of everything. But we're going to apply the rule just the same. So we're going to start out with what we have, our first example, which is 4z to the 5th power times 9z to the negative 12th power. All right. Okay, so what we got here is a combination of numbers and then variables. So we got the numbers, which are coefficients, and then we have our variables. So the rule to doing this first is you're always going to multiply coefficients then multiply variables. As long as they're set up like this. Now we have parentheses that kind of changes everything. But when you're just basic like this, we'll multiply the coefficients first and then we'll multiply the variables. So my two coefficients at this time are 4 and 9. Those are your coefficients. So I'm going to take the two coefficients, 4, and multiply it by 9. Now my variables happen to have, let's switch this color out, have the same base of z. So I'll bring down the same base of z. They also have exponents, an exponent of 5 and an exponent of negative 12. So the rule applies the second that we have, 5 plus negative 12. All right, so now we're going to get to our final answer. So to get our final answer, we'll take and multiply 4 times 9, which is 36. We'll bring over our base that they shared in common, which is z. 5 plus negative 12 is negative 7. Now, once we get to here, they're asking us to simplify. And when they ask us to simplify, now we cannot have negative exponents in our answer. So when you simplify, you have to have positive exponents. So since this z has a negative exponent, what do I do from yesterday's lesson? Who can remember? That is correct, Fabian. I'm going to keep the 36 right where it is and bring that z to the bottom, to the denominator, and give it a positive exponent of 7. So this would be my final answer. All right. We're going to try another one. So bring this up a little bit. Hang on. All right, we're going to try another. We're going to do 2a times 9b to the 4th times 3a squared. All right. Even though we have different variables, a and b, we're still going to do the rule of multiply the coefficients. So we're going to look at our coefficients, which are 2, 9, and 3. And sometimes your coefficient might be 1, so don't be afraid of that. So 2 times 9 times 3. All right, then we're going to do our variables in alphabetical order. So our first variable is a, and we have another a way down here. Now this variable a does have an exponent. Even though you don't see it, it is an understood 1. So if you need to put that in, you do. So the a exponent of 1 and the a exponent of 2, since they have the same base a, we add those exponents, 1 plus 2. Then we're going to move along to our next variable, which is b. And there's only one b, and it has an exponent of 4. So 4. So now here we go. 2 times 9 is 18. 18 times 3 is 54. Then we have a to the 1 plus 2, which is 3. And then we have our b to the 4th power. There are no negative exponents, so that would be our simplified answer. All right, we're going to try the got it 2. At the bottom, there is an a, b, and c. So we're going to do the a, which is 5x to the 4th times x to the 9th times 3x. Then we have our b, which is negative 4 c to the 3rd times 7 d to the 2nd times 2c to the negative 2. And then we got our c way down here. We'll come to the c down here, which is j to the 2nd times k to the negative 2 times j, I'm sorry, not just regular j, 12j, squeeze him in there, 12j. All right, so now we're going to take these three and we're going to simplify them. So earlier I told you sometimes you might have a coefficient of 1. And you'll know that when you don't clearly see a different number. This coefficient is 5. I don't see a number here, so that means my understood coefficient is 1. And my coefficient is 3. So I take my coefficients, 5 times 1 times 3. So to multiply my coefficients together. They all have the variable x, so that's beautiful. They all have the same base, so x. And this exponent is 4. This exponent is 9, so plus 9. But there is an exponent here that we don't see, and it's a 1. So you can't just leave it out. So then you have to add plus 1. So if you need to, when you don't see an exponent, put a 1. And when you don't see a coefficient, put a 1. So that way will help you remember. So now I've got 5 times 1 is 5. 5 times 3 is 15. I only have one variable, and that is x. So I add 4 plus 9 is 13, plus 1 more makes 14. Final answer. No negative exponents. I leave it as is. All right, going on to b. Our coefficient is negative 4, 7, and 2. So I'm going to write those down. Negative 4 times 7 times 2. This time I have two separate variables. I've got a c, then I got this d. All right, so we're going to go alphabetical. So we'll start with our c. Well, c has, since I have two c's, I got to look at their individual exponents. The exponent to the c is 3 and negative 2. So 3 plus negative 2. Then I only have the one d, and it's raised to the 2nd power. All right, so I'm going to go ahead and multiply. Negative 4 times 7 is negative 28. Times 2 is a negative 56. Then I'm going to take my exponents to my c and add them up. 3 plus negative 2 is a positive 1. So I don't need to write a 1. It's understood. Then I just have my d to the 2nd power. So I bring it down. No negative exponents. Final answer. All right, we're going to move on. So looking at c, I don't see any numbers besides 12. So I'm going to go ahead and put these 1s in here. So my first coefficient is 1. My second coefficient is 1. And my last coefficient is 12. So I'm going to bring them down. 1 times 1 times 12. I have two different variables. I have j's, 1j, 2j's. Then I have a lonely k up here. So I'm going to take my j, because j comes before k in the alphabet. I'm going to take the exponent to the first j, which is 2, and add it to the exponent of the second j, which is an understood 1 because there's no number there. So plus 1. Then I'll bring down the only k that I got, which is k to the negative 2. All right, so we're going to multiply. 1 times 1 is 1, and 1 times 12 is 12. Then I'm going to add the exponents to my j. 2 plus 1 is 3 to get my new exponent. And then I've got k to the negative 2. Well, now I've got a negative exponent, so I have to move him. Since 12 and k have positive exponents from yesterday's lesson, 12 and j to the third will stay right where they are, but the k has to go to the denominator and get a positive 2. So now this would be my final answer. All right, so we're going to go ahead and we're going to move over back to page 429. We're going to do a few problems there so I can show you how I want you to set these up for your homework tonight. So we're going to go again to page 429. You're going to be doing the evens, so I'll do a few odds with you. We're going to do number 15 and 19. So number 15 is 5c to the fourth times c to the sixth. And number 19 is negative m squared times 4r to the third. All right, then it's going to be multiplied times 12r to the negative fourth times 5m. All right, so you guys are going to give me a little bit of a hand right here. All right, so let's start with Amaya. Amaya, on number 15, what would we do first, Amaya? Fantastic. I'll put this 1 right here in front of my c to 6 since I didn't see an obvious coefficient. So now, Amaya, what do I do? Beautiful, beautiful. All right, she's saying I need to identify my two coefficients, which are 5 and 1. And then we're going to multiply those. 5 times 1. All right, so Mr. Laquan, how many variables do I have? Correct, I have one variable, but it's repeated twice. Beautiful. So I have a c and another c. I don't have any other variables other than c. So to bring down that c, the exponent to this c is 4, and I'm going to add it to this exponent to that c, which is 6. So we're going to go ahead and simplify. 5 times 1 is 5. And then we're going to add 4 plus 6 is 10. Final answer. This is what I'm looking for on your homework. I want you to be able to identify what are your coefficients, what are your bases of variables, and then what are their exponents, and what operation we do to get to the final answer. All right, so let's move to number 19. So Fabian, tell me what we should do. Beautiful. I need to put a 1 right here in front of that m, so I have all my coefficients now, or my variables now have distinct coefficients. So Ethan, what are my coefficients? Beautiful. Negative 1, 4, 12, 5. So I'm going to write those down. Negative 1 times 4 times 12 times 5. All right, how many different variables do I have, Tanaya? Fantastic. I have 2. I got m's and I have r's. So I got 2 types of variables. All right, so alphabetically, who comes first, Angel? Beautiful, m's do. So times m. And now my m exponent, my first m exponent is 2. My second m exponent is 3, so I'm going to add 2 plus 3. All right, so then that leaves me with my variable r. So my first exponent for my r is 3. And my second exponent for my r, I'll add it to this, would be negative 4. All right, so now I've got all what I need. So we're going to multiply. Negative 1 times 4 is, that's right, negative 4. Negative 4 times 12 is correct, negative 48. And negative 48 times 5 is a negative 240. Beautiful job. I love it. I love it. All right, so now what we're going to do is go ahead and bring down our first variable, which is m, and add those exponents. 2 plus 3 make 5. We'll bring down our second variable, which is r, and we'll add 3 plus negative 4, which makes negative 1. Do I leave my answer like this, Tanaya? You're right, I do not. Why not? That's correct, because we have a negative exponent. So to bring down my negative 240 because it has a positive exponent, I don't want to mess with him. M to the 5th has a positive exponent, so I don't want to mess with him. So now I'm going to move that r to the negative 1 to the bottom. And what does this exponent become? That's right, a positive 1. So I'm going to leave that just like that. I don't want to mess with that. All right, so now we're going to move on to our final example. All right, this probably will be the most difficult one that we'll look at today, just because you've got to understand a little bit of information about scientific notation. So example 3, we got to make sure you understand scientific notation. So this is multiplying with scientific notation. All right, so what we're going to do is first talk about what scientific notation means and looks like. All right, suppose I give you the number 31754, and I'm going to give you the number 017052. Okay, and yeah, I think those would be good numbers. Let's put a 1 and an 8 here. There we go. Yeah, I think I like those. Okay, so now we've got these two numbers with scientific notation. We're going to start first of all, if we see this number, 31,754, and we see this number of 81,017,052, we're going to talk about taking and writing these numbers in scientific notation. Well, currently you do not see a decimal in these numbers, which is A-okay, but sometimes you need to have numbers in those decimals. So our decimal for each of these numbers secretly hides out here at the back end of every number, because when you think about money, you have your number, your decimal, and then you have your change. So you have your number, your decimal, and then your change, whatever it be, your 30 cents, 40 cents, 57, or whatever. To write it in scientific notation, our goal is to have our decimal right there behind the first number, to the right of the very first number we see. So I want my decimal to go right there to the right of my very first number. So that means I want my decimal to be right behind the 3. So 3.1754. And I want it to be right here, so it reads 8.101705.2. With scientific notation, you always write times 10 to the something. And that power that we're going to put right here and right here tells me how many places I move my decimal. So if I move my decimal to the right 1, 2, 3, 4 times to the right, so my decimal would be 4. Here, if I move my decimal over 1, 2, 3, 4, 5, 6, 7. So my new exponent would be 7. This tells me I move my decimal from the right to the left. So when you move the decimal, when the decimal moves from right to left, you have a positive exponent. Move this up. All right? So the next thing we're going to talk about when the decimal is on the other side. Okay, so sometimes our decimal will not be on the right, but our decimal will start on the left. So we're going to start that 0.00372, and we'll do 0.0134. Nothing crazy. All right, so now this time, our decimal is already in existence, and it's starting on the left-hand side instead of on the right-hand side. So again, we still want our decimal to be moved right to the right of our first non-zero number. So zeros to the left of the number are really not that much important as long as they're just zeros. So as I move to the left, I want to come to the first non-zero number, and then I want to put my decimal there. So I start from the left, I go to the right until I find the first non-zero, then I want my decimal to be right here. So that means I need my decimal to be at 3.72 and my decimal to be at 1.34. Now with scientific notation, again, it's always going to be times 10. And then we got to figure out how many places we move it. So my decimal starting on the left-hand side and moving right, 1, 2, 3. So since it's starting on the left side means negative, and it went to the right 3 places, so negative 3. So my decimal here started on the left side, so my exponent will be negative, and then I go over 1, 2 places, so negative 2. Alright, so this is important first of all to understand how that scientific notation moves. Because when we start to solve exponents or powers that have them, sometimes they don't move our exponent far enough, and sometimes they move it too far. So for instance, if my decimal stopped here, I would have only had an exponent of 1, 2. But I would have had to move it over another 1, 2, thus making the number increase from 2 to 4. So we're going to kind of show you that in a story problem, and that's going to help us to make a little more sense of this. So we're going to go ahead and bring this down and switch this over, change our page, and give us a few different couple of problems here for us to look at. So in your book, on page 427, there is a story problem. So if you don't have your textbook, go pause the video, go grab it, come back, and we want to be able to look at that. All right, I'm assuming you're back with your book now. So our story problem is on chemistry, and it says at 20 degrees Celsius, 1 cubic meter of water has a mass of approximately 9.98 times 10 to the 5th power grams. Each gram of water contains about 3.34 times 10 to the 22nd power. All right, of molecules of water. About how many molecules of water does the droplet of water shown below contain? So now it has a volume in here, which is, they give us a lovely formula. So I'm going to write this down here too. It says volume is equal to 1.13 times 10 to the negative 7. Alright, so we're inside your story problem, and they're asking us to analyze the information that we have. To do this, they want us to take our 3 things, and they want us to multiply them together. So they want us to take our first one, which is the 9.98 times 10 to the 5th, and multiply it by our second value, 3.34 times 10 to the 22nd. And they want us to multiply by the last thing, which is 1.13 times 10 to the negative 7. Now in scientific notation, they do use these x's for multiplication, the old multiplication symbol you learned before you started learning algebra. So when you're using these on Math Excel for school, there is that toolbar down below that has this symbol. You cannot use the X on your keyboard. If you just use the X from the keyboard, it's going to mark it wrong. So you have to use the time symbol that looks like an X down below where you find like your boxes for making fractions and exponents and square roots, etc. So this is where you'll find this little X at, and it's important that you use that. Alright, so we're going to use the same concept we did earlier in the lesson. We're going to identify our constant or our coefficients, and then whatever has the same base. So our coefficients are 9.98, 3.34, and 1.13. Those are your 3 coefficients. So I'm going to write those down. 9.98 times 3.34 times 1.13. Alright? So that's our first one. So we kind of put these together in a grouping. So those are our coefficients. With scientific notation, remember I told you that you're going to use this little time symbol, the old school time symbol. It's not an X, it's the old school time symbol. Then we're going to take the components that have the same base. So we got a base of 10, a base of 10, and a base of 10. So we're going to keep our same base, 10. Remember that the same base, we add our exponents. So my first exponent is 5. And my second exponent is 22. And my last exponent is negative 7. This is my final part there. All right, so now you're going to break out that trusty rusty calculator of yours. So I'm going to bring that rusty trusty calculator up in our screen so you can see it okay. We're going to put in our numbers, 9.98 times 3.34 times 1.13, and then I'm going to change it to a decimal. Oh, there it is, beautiful as it is. So I'm going to go ahead and write that value down. So 37.6666516. All right, so that's what I get when I multiply those values together. All right, so then I've got times. And then I'm going to bring down my base of 10. And I'm going to add my exponents. So 5 plus 22 is 27. 27 plus negative 7 is a positive 20. All right? So now we can see this means, for me, my decimal, I'll bring back my old paper for a second ago. It means my decimal started way over here on the right somewhere. And I moved it over 20 spaces to get it to where it currently is. So that means this decimal started way back here somewhere. And I moved it over, let's see. So this would be like 14, 15, 16, 17, 18, 19, 20. So I moved it 20 spaces to get to here. But it is not in the correct spot. Remember, my decimal is supposed to be right into there. So if I had moved my decimal over bam, 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 that represented 20. I need to move it over one more additional time. So 1 more than 20 would be 21. So 3.7666516. And since I had to move it over one additional spot, it becomes 21. So again, this means my decimal had been moved over 20 spaces to get to here, and I need to move one more additional space to get it into the correct spot. All right, so now we're going to go ahead and we are going to turn in your books to page 429, and I'm going to give you a head start on this one. Page 429. Now you have to do the even, so you're responsible for 20. So I'm going to go ahead and get you started on 20. It says biology, a human body contains, oh, we got an astronomy one. I think we might pull that one. I'll just go and get you started. We have a human body contains 2.7 times 10 to the 4th microliters of blood for each pound of body weight. Each microliter contains 7 times 10 to the 4th power of white blood cells. About how many white blood cells are in the body of a 140-pound person? Okay, so we got our values here we want to look at. We have our first value, which says 2.7, our little time symbol, 10 to the 4th. That's our first value. Times our second value, which is 7 times 10 to the 4th. And then times the weight of a 140-pound person, so times 140. So again, you're going to do this by, remember, bringing down your coefficients, the 2.7, the 7, and the 140, and multiplying together in a group of parentheses like this, your time symbol, and then times 10 to add your exponents. Then you'll multiply and get your new value, and then you'll add your exponent to get your new exponent, and then determine how many more additional spaces you need to move to get it to the right spot. And since we had to move one additional spot, we up this by one additional number. All right, so that's the end of our lesson today. Remember, your homework is on page 429 tonight. You're doing the evens 8 through 20. Have a great day.